Well, hey there, everybody. It's your boy, Mr. Perry, and here we are, the final video in Unit 3. We're going to start by talking about Kroger. So let's say we have two different Krogers. One is located here, and one is located here. I want you to pause the video here, and I want you to consider our questions that you have down here. What would these two Kroger locations have in common? How might they be different? Identify 2 or 3 ways that these two Kroger stores would offer similar shopping experiences for their customers, and 2 or 3 ways that they would be different. So we're looking at, again, one Kroger that's located in Wixom, Michigan, and then we're looking at another Kroger that's located in Beverly Hills, California. Go ahead and pause the video, take a second, and just jot down a few ideas about how you think these two Krogers would be similar, as well as what would be some of their key differences. I'm going to assume that you've paused the video and we are ready to move on. So obviously these would have the same name and they would have some of the same items, but there would be most likely some pretty significant differences between shopping at the Kroger in Wixom, Michigan versus shopping at the Kroger in Beverly Hills, California, if they even have a Kroger on Rodeo Drive in Beverly Hills. So question to kind of ponder here is, would it be more accurate to say that the Kroger in Wixom is equal to the Kroger in Beverly Hills, or would it be more accurate to say that they have the same name? And considering, what we know about locations and how that can impact shopping experiences, I think it's pretty accurate to say that they have the same name, not necessarily that they are equal, because we would expect things to be a little bit different, even though they have the same name. Now, we're going to go ahead and jump in to lesson 7 here, which is about comparing objects. So let's go ahead and get started here. So far throughout this lesson, throughout this unit, we've been comparing different data types using Boolean expressions. So, it's pretty easy at this point. Hopefully you've practiced it enough that you've got a really good handle on what this means. If we want to compare primitive data types, we use our two equal signs. So if we want to see whether or not the winning noom is the same as the lotto noom, then we would need a selection statement like this: if winning noom equals lotto noom, and that's going to go ahead and test whether or not our two ints are the same. We have also learned about strings, and we know that there is a method called the equals method, which will test whether or not one string is the same as another string. And so strings, as well as objects of a class, should be tested for equality using the .equals method. So if I had string class name equals APCSA and then string other class name equals APCSP, I could say, if class name dot equals other class name, go ahead and print true. Well, of course, they don't match. They're not the same, so this one would print false. So the equals method is what we use with strings as well as objects of a class to see whether or not they are storing the same values and contain the same data. Here's another one here, reference data types, again, objects of a class. We can also test them for equality using the .equals method. So here we have two pet objects. Pet my pet equals new pet with furball and 8. And then pet your pet equals pet, furball, and with 8. And down here what I'm doing is I'm saying if my pet.getName dot equals your pet.getName. So again, we're calling the getName method with my pet, which is going to return furball, and it's going to see is furball equal to, and we're calling the getName method with your pet, which is going to return furball. So obviously furball equals furball, so that's going to return true. So what happens if you compare reference data types using the equals sign instead of the .equals? So what if I created two album objects and said album 1 equals new album, and let's say I went ahead and passed in Kendrick Lamar's To Pimp a Butterfly, and let's say I did album 2 equals new album, and I passed in those same instance variables. It turns out if you print album 1 equals album 2, we're going to get false. It's going to say, nope, these are not the same when I test them for equality using equals equals. And that's because of, if we go all the way back to lesson 1 from unit 3, that's because of the whole concept of aliases. So remember that reference data types, in terms of how they operate in Java memory, every time you create an object of a class, the object name, in this case Baxter, is a pointer. It's a reference to an area in memory where all of this object data is being stored. So Baxter and 7 are being stored at this memory location over here. Now this next line of code, pet snowball equals new pet, snowball and 8. Again, our variable name snowball is a pointer. It is a reference to an area in memory where all of this is being stored. But then remember, if I do pet my pal equals snowball, what this does is this creates a new variable of the data type pet, but it sets it equal to snowball. So what we've just done is we've created an alias of snowball called my pal. And snowball and my pal are now aliases of one another because they point to the same address in memory. And therefore they are equal in terms of their object references. If they point to the same memory address, then they are equal in terms of their object references, which means when we try to test them for equality using the equals equals sign, we'll get some outcome here. We're going to get some true and false outcomes. So let's go ahead and see what's going on. So testing reference types for equality, we use equals equals when testing whether or not reference types have the same memory address or whether or not they are aliases. So right now, Baxter is not an alias of snowball. These guys reside at different memory addresses. So when we print, does Baxter equal snowball, we get false. Now, snowball and my pal are aliases of one another. So when we print snowball equals equals my pal, we get true. However, Baxter is not an alias of my pal. So when we print that one, we get false. Okay. And again, the only reason why we're getting true right here is because snowball and my pal are aliases as indicated by this line of code right here. So similarly, we would not say that the Kroger located in Wixom is equal to the Kroger located in Beverly Hills. They are clearly not in the same location. They're not in the same memory address. So therefore, Wixom is not equal to Beverly Hills, or the Kroger here is not equal to the Kroger over here. However, they do have the same name. Excuse me. We could say, if we ran the line of code wixom.getName and then .equals and then in parentheses Beverly Hills.getName, this would evaluate to true because they're both called Kroger. The name of both stores is called Kroger. So when we call getName here, it's going to be Kroger. And when we call getName here, it's going to be Kroger. So Kroger equals Kroger would be true. That would evaluate to true. So in order to make this print true, if we go back to our album object example here, in order to get this to print true, album 1 and album 2 would need to be aliases. So they would need to point to the same memory address. So I would have to alter this. Instead of saying album 2 equals new album and, again, assigning it to a different memory location, what I could do is I could say album 2 equals album. So now album 2 is an alias of album 1. And when we print album 1 equals album 2, we're going to go ahead and get a true value that time. All right. And by the way, string objects do behave the same way. Down here, we've got string class name equals new string, APCSP. And then string second class name equals new string, APCSP. And then string third class name equals class name. So third class name is going to be an alias of class name. And even though these are all string objects, they still will operate the same way. So if we print class name equals second class name, is class name an alias of second class name? No, it is not. We would expect that to be false. And then if we print second class name equals third class name, all right, is second class name an alias of third class name? It is not. So we would expect that to print false. And then if we print class name equals third class name, all right, so now class name actually is an alias of third class name because of this line of code right here. So when we print this, we would get true. So this would print false, false, true. Finally, if we switched it and we used the dot equals method instead, now we're testing, do they actually contain the same characters, right? So class name dot equals second class name. Well, let's see. Class name is APCSA. Second class name contains APCSP. So we would expect that to be false. Second class name dot equals third class name. Let's see. Second class name is APCSP. Third class name, let's see, since it's an alias, is going to be APCSA. So we would expect this one to be false as well. But if we printed class name dot equals third class name, these are aliases. So class name is containing APCSA. Third class name is also containing APCSA. So we would expect that also to print false, false, true. All right, guys. Well, that's been a lot of information here. Let's go ahead and do our lesson review. So oftentimes classes have their own dot equals method or their own equals method, which can be used to determine whether two objects of the class are equivalent. Two object references are considered aliases when they both reference the same object and when they both point to the same memory location. Object reference values can be compared using equals and not equals to identify aliases. So if you want to test whether or not objects are aliases to one another, you can test them using those relational operators. A reference value can be compared with null using equals or not equals to determine if the reference actually references an object. And we're going to be looking at some practical examples or some practical applications of that in class. All right, guys. Well, here we go. We're done with Unit 3, Lesson 7. We're done with the unit in general. So thanks so much for watching. Make sure you leave a question or a comment. I'll see y'all in class.